to give you a very short background on SIP authentication, the standard one that you use when you use a proxy. Whenever this guy has to give a call, and he's using a proxy, he will do an invite. And the proxy will challenge him, will tell me, okay, you have to show that you are the real one that you're pretending. So it will give him a nonce, and based on this nonce, based on some secret, common, shared password, well, secret, actually shared secret, based on the realm and the algorithm that has to be used, the device has to send back the hash of that particular nonce coupled with all this particular information. So username, domain, realm, and the nonce. And in this way, the device can know that the entity that it's pretending to be Bob, it's a real Bob. And this is a sound algorithm. In terms of cryptology, it's really, cryptography, it's a good one. It cannot be broken very easily. What we have discovered on the Cisco Call Manager on OpenSafe, for instance, is that tokens can be reused. So for efficiency reasons, most servers, whenever they receive a token, they will not check if it has already been used already. So it will say, okay, it sounds to be valid, so I'm going to accept it. I'm not going to check, to implement a checking routine to see, have I already used it? So for these two particular implementations, for these two particular proxies, which have been disclosed right now, we are disclosing, and there are some others which vendors are still implementing the patching, so we didn't release disclosures yet. Basically, most of the proxies do it. Well, if a bad guy is kind of intercepting this call, he can reuse the token. You just grab the token from the packet, and the nice thing is that you can call anybody. Normally, the token, it's computed also on the URI that you are calling. So if this entity is calling, I think it's B is here, user B, normally the token that is sent over here, it's computed based on the remote destination. Well, all the implementation that we've tested do not check anymore. So they receive the token, they will see that it's valid, and they will allow you to do a call to any other location. So it's a kind of error in implementing a real access control implemented. It's not standard man in the middle. It's not like I intercept a call and then I just do it one more time. I intercept a call and then I can reuse the token. It might be Call Manager, for instance, allows you even to generate your own nonce, the token, and to send it back. So it doesn't even check that the nonce has not been generated by itself. Now, Voiceover IP can be also bad from your internal network point of view. So most attacks until now have been so like somebody from the network will attack your Voiceover IP network. And we try to imagine the other way around. Can I use Voiceover IP as a kind of universal firewall hole mechanism? Most Voiceover IP calls will go through firewalls. Firewalls will see that SIP traffic. I know how to deal with SIP traffic, so I will allow it. There's no kind of filtering performed on the firewalls on the data field itself. And all this traffic will go directly there where your assets are, on the internal network. They will go to your Voiceover IP equipment, which is in the most protected network, or at least it should be. So one nice attack, conceptually it's nothing new. But it's not new that you can use SIP, for instance, to do cross-site script request forgery. Most Voiceover IP phones have a web server, which is embedded. And you can use it for configuration, or you can use it, for instance, to see who called you while you were not there, so checking the missed calls. And this particular vulnerability, it's affecting the Linksys phone. That's a Linksys P941 phone. You can do invite, so you can just use simple SIP. You put JavaScript in it, and it will get executed on the web browser of the person who is trying to see if it missed any calls. And you cannot deactivate JavaScript because the configuration will not work anymore. So you're forced to use JavaScript, to enable JavaScript on your internal machine, and then once you receive these calls, well, we know what JavaScript can do. So I'm not sure how many have seen the presentation of Jeremiah Grossman on how to deactivate firewalls with cross-site script request forgery. So just push JavaScript on the machine sky. When the machine will connect, well, JavaScript will get executed. You can scan the internal network. You can do something like what we did with USB. So for instance, you can see all the zombies that you have infected, and you can also exploit against the internal machines. It's really very nasty things that you can do with Linksys. And in most IT departments, they will never think that, well, you can have JavaScript injected with SIP and execute it on the machine. So it's really as bad as it can get. How to do toll fraud? most proxies, most, I would say, accounting software will extract data from SIP headers and will use it to put it in some database. And for instance, in Asterix, there are some plugins which will take, or add-ons that will take this data and will make tables, for instance, where they store the minutes that you have been calling. And, well, they take raw data from the SIP. So if you, well, this is a small simplification because the real code, I mean, the real expression was a little bit too long. But if you put some SQL statement over there, well, it will get executed by the proxy. So for instance, with this expression over here, we are asking the server to reduce by 10 seconds the number of stored minutes that I have been kind of registered for using the proxy. So you can do very simple toll fraud by just reducing the number of stored minutes on your server to something insignificant. Now, if you think though, I'm injecting SQL will be put, the data will be executed by proxy, so it will be put on the database. So I can go further on and think that an admin will at some time moment check the database, and it will do it on web browsing stuff. So instead of SQL injection, we can put JavaScript. And in this particular vulnerability, for instance, we can actually, instead of injecting a SQL expression, we can inscript a JavaScript, which will be stored in the database. And once the admin will try to see, kind of accounts and what has been used by everybody, he will automatically get attacked with a cross-attribute request forgery, for instance. So whenever we have a kind of SQL injection possible with SIP, well, we can also put JavaScript in it. So we can also go and take down the internal network if we want. There's a nice feature in SIP which is called the Reinvite. And the Reinvite allows, okay, I'm going to establish a session. Everything was fine. And then, for instance, there's some network congestion. So I need to change the codec. That's one option. Or I'm going to service mobility. I'm going to enter a room. There are some nice loudspeaker. And I'm going to use the voice to that loudspeaker. So there is an option which can say, in the middle of a session, I want to renegotiate the RTP session. And it's done with a Reinvite. So the entity that wants to do a Reinvite will just send somewhere in the middle of the session an invite. And obviously, for security purposes, the designers of SIP thought, okay, if I'm going to receive a Reinvite, I have to make sure that the one who's sending it is the right entity. I don't want to have call hijacking. That's kind of related to the threat model they had. So I'm authorized to challenge the entity that's inviting me to say, okay, prove me that you are the right one, that you are. And you can use this security feature in SIP to do toll fraud. And it allows you to do toll fraud on any network. And I'm going to show how we can do it. So assuming you are the bad guy, and you are calling, doesn't really matter, particular user. You can do it on any SIP phone. All of them will affect it. There are two particular information that are interesting here. There's a contact, and actually they are in red. There's a contact, which will tell to this entity, okay, the entity who knows about me, who knows how to contact me, is this particular IP address. Not sure. Yeah, that's here already. And the next field is the record route option. In SIP, you can tell to a device, I want to be in the middle of the session negotiation, all the future messages are going to be exchanged. So I'm going to fill out the record route. And then I do the standard SIP. I'm calling the entity, it will reply, and then I have to trigger a Reinvite. Triggering a Reinvite can be done either by a small denial of service, or, for instance, to ask to be transferred. So I will say, for instance, I'm calling the main desk, and I'm going to say I'm going to be transferred, I don't know, to the sales department. The moment when the transfer will be done, a Reinvite will be triggered. So this is the Reinvite, which is going to send back. In the same time, the bad guy will try to authenticate to the proxy. It will try to authenticate, it will receive a nonce, but it doesn't know the password, it doesn't know the secret that is shared only between this guy and the proxy. So what it will do, it will, whenever it receives a Reinvite from the hacked user, it will ask him to do the job. It's called in cryptography the grandmaster attack. You're playing with two grandmaster chess, you're playing white with the other one, black with the other one, and you are kind of proxying the request in between the two. So we are asking the good guy to do the job for you. It will authenticate, it will send you the reply, and at this time moment, you are going to use the reply and send it back to what is called the $1 million idea.